Hi everyone, welcome back to our series on C++ development with Visual Studio Code. I'm Alexandra Kemper, and today we're diving into the world of build systems. In our last video, we explored the C++ extension's new walkthrough for running and debugging your code in a single file. If you're looking to get set up in VS Code for C++, check out that video first. What is a build system? Imagine you're working on a new C++ project. It's just a single file, you can still manually compile it, it's not a problem, and you can just do this in the command line. But as your project grows and you start having more and more files, more and more dependencies you need to manage and targeting different platforms, your project starts getting super convoluted and harder to manage. This is where a build system comes in. A build system is a set of tools and processes that can track how you want to compile and link your code. You just need to describe your project's structure and dependencies, and it will generate any files you need to build for you. This saves you a lot of time and reduces the chance of making errors. So examples of build systems include Make, Ninja, MS-Build, CMake, which is a meta build system that actually lets you create any of these other build systems from the same file. And CMake is a really popular choice in the C++ community and has first-class support in VS Code. It's managed by Kitware, and it offers a lot of powerful features for managing large projects, handling dependencies, and supporting cross-platform development. Let's take a closer look at CMake. You can start off by installing CMake using the link in Kitware's documentation. In my case, I'm on a Mac, so I'm going to choose the most recent stable release for a Mac. If you're on a different operating system, you just choose the right release candidate for you. Then you just click on the download. Now I have a little pop-up that I need to add CMake to my applications. And I can now close this and start coding. For the best experience using CMake in VS Code, you need to install the CMake Tools extension. This extension makes it easier to manage CMake projects. The CMake Tools and C++ extension actually work hand in hand. CMake Tools handles interfacing with the build process, while the C++ extension provides IntelliSense and debugging. In VS Code, just click on the extension icon in the activity bar. From there, just search for CMake Tools in the search bar, select the extension, and then click on Install. There we go. Now the machine has everything you need. You have CMake, the CMake Tools extension, and from our previous video, you have a basic C++ project, the C++ extension, a C++ compiler, and a debugger. Now, let's go back to the project that we originally created in our last video as a starting point. We want to open our code, which just printed out a basic string, and in this case, we're going to update the string so it's more relevant in our case since we're building C++ code using CMake, and we're going to save that. So now it's going to print out, congrats on building your C++ code using CMake. Now we need to actually configure CMake, and we need to tell CMake about our project and how it's set up so that it knows how to build. This process is only going to take 3 steps. Step 1 is that we need to create a CMakeLists.txt file. This is required in every CMake project. It is the central configuration file that informs CMake on how to build, such as the project configuration, build targets, and compiler options. All you need to do is just create a new file in your project and then name it CMakeLists.txt. It's very important that you name this file exactly CMakeLists.txt so that CMake is able to identify this file in your project. I've just pasted what my CMake project needs. However, each line depends on what you want the CMake build system to do for you. So let's go through it line by line, and some of these will probably also apply to your project. First, you need to specify the minimum CMake version required by your project, which in this case is 3.0.0. Then you need to assign a project name, which in my case is my CMake project. This can be any name you want it to be. I also specify the languages used in this project, which is C and C++. The CXX just stands for ++. You can also optimally include ctest, which is a testing tool included in CMake. Enabling it, which is what I do on line 6 here, make sure that you can actually call the commands make test or ctest to run tests for your project in the future. But now comes the most important line, which is to add an executable. This is where I just decide the type of executable which I want to generate through this project. So in my case, I want this to be an executable target called my CMake project, which matches my project name. And it will be based on the source file, mycppcode.cpp. Finally, I also added an extra line to set the property of my target to be the C++ language standard, so that this information is passed over to the C++ extension and can be used for IntelliSense in my code. There are a lot more customizations you can do to this file as your project grows. So for example, you can add more advanced testing scenarios or packaging dependencies using add_package. And if you're looking to add CMake to a more complex repo and need more information on how to edit your CMakeLists.txt, check out Kitware's documentation. They have a lot of tutorials on how this process works. Now that we have a CMakeLists.txt, step 2 is telling the build system what settings to use when building our project. There are 2 different ways of doing this in VS Code, either using CMake Presets or kits and variants. We recommend using CMake Presets to manage your CMake configurations. So today, we'll be using presets. A presets file is just a JSON file that lets you group settings together. This is necessary because you often need different settings depending on the platform you're building for. For example, presets can include your generator. If you want an executable for a Mac machine, you will likely need a different generator than on Windows. With presets, you can have a preset for Windows and one for Mac. This makes it really easy to share configurations with other developers and to add to a continuous integration system. Now, as you add more and more code to this project, the process to build and run won't change. You don't need to compile using longer and longer commands. You can just build and run with 2 clicks. If you have any questions on how to get set up with CMake or other C++ topics you want to learn more about, feel free to leave a comment below or to contact us on GitHub. To add the preset, you just need to create a new JSON file called CMake Presets.json. I've already written my CMake Presets.json, so I can just paste this in and make sure that it saves. But let's walk through this line by line so you know what a normal presets file looks like. First, you need to define a default preset, which is what we're doing here. Then you will see a list of settings for that specific preset, which includes a generator, which since I'm on a Mac, I'm using Makefiles. If you're on like a Windows machine, this could be Ninja or another generator. You also need to specify a binary directory, which is the place where the CMake will place all the executables into. So in this case, this is the build folder. I have 2 different cache variables which set the build type to debug. Make sure you definitely have this line or have some sort of build type, either debug or release or something else. And I also set the export for compile commands to true. Now, you don't need to do any extra work to make sure that the CMake tools extension and CMake itself will be able to find the presets file in your project when you build. So you do not need to reference CMake presets in CMake lists or CMake lists and CMake presets specifically. CMake will actually search through your folder and identify these files based on their name because they're standard names. Now for the 3rd step to set up CMake on your machine, you need to select a build target. This is the final product you want to receive after building. In this case, I want an executable file I can run, so I choose my project executable. First, I need to reload my window since I just installed some new extensions. So I'm going to use the command prompt to do that and just use the reload window command. Now you should be able to see the CMake sidebar pop up on the left for you and the CMake icon be available in the activity bar. Next, I'm going to select my build target. So I should now have the CMake command available to set my build target. And I want this build target to be the same name as my project name. So in my case, it's my CMake project, which is the name I chose in my CMakeLists.txt. Now, when I navigate over to my project status in the CMake side panel, you can see that I am in the correct folder and I have my build set to my CMake project. And so now that the CMake Tools extension is aware of how I want to build my project, you can use CMake to generate all the necessary build files. And this is where you can sit back and let CMake do all the heavy lifting for you. You just need to select the configure button in the side panel. And now you can find any of the generated build files in the build folder of your project. Now you can use those files to actually build using the build all projects button in the side panel. This will create the final executable you need to run your code. You can also use the project outline to select a specific target to build for, but this is optional. Once everything has been built to your specifications, you can just run your code using the play button in the status bar. There we see the output that we expected our program to produce. So congratulations, you just successfully used CMake with the CMake Tools extension. Don't forget to like and subscribe. Until next time, happy building.